As previously we discussed about Schottky diode. So in that last class we discussed about that Schottky diode, how Schottky diode was working of Schottky diode, how Schottky diode was there, and so this is we discussed about last class. And now coming to that next concept, that is nothing but PN junction, the PIN diode. So it is like a PN junction diode. So whatever the PN junction diode we discussed it previously, so same like that. PN junction diode type only is PN junction diode semiconductor type only. The major difference between PN junction diode and PIN diode is nothing but in that PN junction diode it has P type and N type terminals. Here the difference between PN junction diode and PIN diode is nothing but here P type element is there and N type element is there, and between the I intrinsic element is also there. So that's why the name it is called as PIN diode. P type, intrinsic type, N type. So it is nothing but PN PIN diode. So same that is nothing but that is discussed here. The intrinsic semiconductor region between P type semiconductor and N type semiconductor. This is nothing but semiconductor, intrinsic type material. So that is in between P and N. So this is nothing but symbol of PN diode. So this is nothing but symbol of PN diode. The symbol of PN junction diode, we already know that this is the symbol of uh, PN junction diode. So the slight difference between PN junction diode and PIN diode is nothing but here the middle is like some arrow. So this is nothing but PIN diode. Okay, so PIN diode operates and exactly same as normal diode, same as PN junction diode. It operates as the difference between PN junction and PIN diode is nothing but PN junction diode works on very low frequency ranges, but the PIN diode works on high frequency ranges. High frequency ranges, which means that radio frequencies, microwave frequency ranges. So it works on hedges hedges range. It works on megahertz range. So radio frequency, microwave frequency ranges, we already discussed types of frequency ranges: low frequency, middle frequency, high frequency, very high frequency, ultra high frequency, microwave frequency. Those frequency ranges it works. So how it works, that much of high frequency switching, um, in that we discussed. So here this is nothing but intrinsic region stores the charged carriers. So whatever we discussed that here the intrinsic part is there. So it stores the charged carriers. Due to that, the total um, the diode does not turn off until the stored charged carriers is removed. So the diode was do not turn off until stored carriers stored charges carriers was there already, so that can be removed. It works on high frequency ranges, we already discussed. So it not enough to remove the stored energy. So if we applied high frequency range, so it is not remove that stored energy whatever that intrinsic material have. So the PIN diode was like a current control resistor, and so whenever it is applying zero voltage range or reverse bias condition, what will happening on that, so it acts like a low capacitance and a high impedance. The PN junction diode, the PIN diode, which is made up of silicon material. Why? Because silicon material have high resistivity and it is easily fabricated. The fabricate means that in VLSI we discussed that. So fabrication means made of diodes. It is easily fabricates. The working conditions of PIN diodes is nothing but forward bias as well as reverse bias, two conditions. So in that, zero or reverse bias condition first we discussed in PIN diode as a low capacitance. The low capacitance will not pass much radio frequency signals, means that high frequency signals we cannot pass in that reverse bias conditions. Only forward bias condition it allow to pass high frequency radio frequency signals. As reverse bias voltage is applied to the device, depletion width starts increasing. Whatever the depletion region is, that is increasing in that reverse bias conditions, and the device functioning as a capacitor in reverse bias condition. So we already discussed that. And forward bias condition, what will happening on that forward bias condition? In this case, forward bias, the forward voltage provide to the diode charged carriers from P and N regions are means that the whatever the depletion region injected into the intrinsic region, so intrinsic region is decreased. Means that the forward bias condition, pin diode behaves as a variable resistance device. So the characteristics of pin diode is nothing but low capacitance, store carriers, high breakdown voltage, etc. The applications, so mainly the pin diode asks two marks question. So uh, the mainly remember these applications, it can be used as microwave switching, variable attenuator, modulators, phase shifters, used radio frequencies, etc. These those are nothing but main applications. Remember these applications, one of the most important question for 2 marks. And students, try to complete your notes. So this is the last concept of this unit. So you must complete notes. Thank you.